In this video, we'll look at the converse of the Pythagorean theorem and how to use it. So a converse, if you're like me, you think of the shoes. But in math, a converse of a statement switches the order of the if-then statements. So we're going to look at the two below to kind of get the feel for these. If I start with the if-then statement, if a number is divisible by 2, then it's even. The converse will switch that order. So the converse would be, well, if a number is even, then it's divisible by 2. And my second one, I have, if a shape is a square, then it has 4 sides. Its converse would be, if a shape has 4 sides, then it's a square. So if you look at these two examples, they're slightly different because in this first one, if a number is divisible by 2, then it is even. Its converse is true. If a number is even, then it's divisible by 2. So both of those, no matter what order, are true. In the second one, however, if a shape has 4 sides, then it's a square. That's false, or at least it could be false, because it could also be a trapezoid or a rhombus. So here, only one of them is true always. But hopefully that gives you the feel for what a converse statement is. So looking at the Pythagorean theorem, we know it's only true for right triangles. So an if-then statement for the Pythagorean theorem would be, if a triangle is a right triangle, then we know a squared plus b squared equals c squared. The converse of that would be, well then, if a squared plus b squared equals c squared, we know it's a right triangle. And in class, we did a gizmo on this to kind of test it out, and we found that that converse is true. It's only going to be a squared plus b squared equals c squared if you have a right triangle. So what that means is we're allowed to use a squared plus b squared equals c squared to prove if a triangle is a right triangle or not. So if a squared plus b squared works out and is equal to c squared, I know it's a right triangle and not another kind of triangle. Next, we're going to look at 2 examples of those. So my 2 examples say, determine if the following triangles are right or not. So to do that, I have all 3 side lengths. I'm going to plug those into a squared plus b squared equals c squared and see if it's in fact truly equal or not. So with this first one, first thing I'm going to do is label my sides. So I see I have my right angle here, which means 85 degrees would have to be my C. And then I'm going to call 84A and 13B. Remember, it's okay if you said 84 was B and 13 was A, but C has to be 85. So next what I'm going to do is plug those values into a squared plus b squared equals c squared. So what I would have is 84 squared plus 13 squared, and I'm trying to see, does that actually equal 85 squared? So 84 squared is 7,056. 13 squared is 169, and I'm trying to see if that equals 85 squared, which is 7,225. So what I'm going to do is actually add together that 7,056 and the 169, and it in fact does equal 7,225, which is my c squared. So when I get 2 things that are actually equal to each other, it means that a squared plus b squared does equal c squared. Therefore, this has to be a right triangle. Now, if I look at the next example, it's slightly different. I don't have a picture anymore. I just have 15, 21, and 12 listed as my sides. The important thing to note is to pick out that longest side length because I know that it has to be C, or my hypotenuse. So looking here, 21 has to be C. 15 and 12 would be A or B. So I'm going to say 15 is A and 12 is B. But I know the 21 has to be my C value, so be careful for that. I'm going to start the same way I did with the other one, which is plugging those numbers into a squared plus b squared equals c squared. So here I would have 15 squared plus 12 squared, trying to figure out if that equals 21 squared. So 15 squared is equal to 225. 12 squared, you can hear my calculator in the background, is 144. And I'm trying to see if that equals 21 squared, which is 441. So looking here, I'm going to add together 225 plus 144, and that gives me 369, which is not, in fact, equal to 441. So therefore, I know that this is not a right triangle because it does not satisfy a squared plus b squared equals c squared. So that's how you test using the Pythagorean theorem if a certain given triangle is in fact a right triangle or not.